Hello, and welcome to the first in a series of videos that will discuss different methods of creating facial animation through the use of 3D programs such as Autodesk Maya, Blender, and 3ds Max. This project was started by my thirst to learn more on animation during my time at Purdue, and it is my hope that the information I share will help you on your journey to learn more on character animation. We will start off by discussing briefly on what those methods are, along with how to set up the head model for one of them. In these lessons, I will be using Autodesk Maya 2013 Student Edition. Let us begin, shall we? There are 6 different methods to choose from for animating the face. Those methods are joint-based, shape-based, curved-based, texture-based, motion capture, and last but not least, Maya Muscle. Now I know probably some of you are just a little bit curious about the last one. So let's start off with Maya Muscle. This is something that's a little bit more recent with the release of Autodesk Maya 2008 that has been tested and played with by other students, such as yourselves, with one even using it as their senior project. Hint hint. The idea is to simulate the muscles in the face using the Maya Muscle tool, much in the same way one would use to simulate muscle movement in the arms and legs. Now, while I haven't seen or heard anyone use this type of method in the professional field as of yet, I thought that since the idea is out there and that some people are trying it out, that I would at least make a mention of this method. Then I want to try it out myself and share the results in a future video. Now this next method on our list is something I think we've all at least heard of at one time or another, called motion capture. This is a process which uses multiple cameras and laser scanners to capture movement on a live person's face and record the coordinates of those different positions into a database that is used later on for animations in movies and video games. Sometimes this method is also used in conjunction with another one on our list to create a cleaner transition for when aspects of it don't go over as smoothly as it should. This method is called the shape-based method. It uses the blend shape tool to change the shape of the face into different expressions using multiple morph targets. Instead of using polygon transformations to animate the face, texture-based animation manipulates the textures on the models instead. This method has been used in older video games along with 3D cartoons. Our next method, called the curve-based method, uses NURBS curves to influence movement in the character model's face that is bound to control joints. And the final one on our list is the joint-based method. Also sometimes called the bone-driven method, it is used most often with animating character models in video games, since most game engines support it. In this video, we will be setting up a character head model using the joint-based method. It is a long process and can be a little tedious, but it gives a lot more control to the user on how they want their face to move in even the most subtle ways. So you must be wondering, how many joints do we need? Well, that depends on how much detail you want the animation to have. In the head alone, the amount of joints used can be as high as 90. This was the amount used for the main characters in Naughty Dog's latest PlayStation 3 game called The Last of Us, in which they wanted to have even the most subtle movements to make the characters feel more alive. So now that I have described the joint-based system and how it functions, the real fun can begin. Here we have our head model. We will start by creating the joints that will make up the spine and for the movement of the whole head. Make sure you are creating the joints in the side or top views, since you will only be able to create them on a grid and not empty space, such as the side view. Start by going to Skeleton, and then select the Joint tool in the main menu bar above. If that option is not there, then go to the pull-down menu on the upper left corner and select Animation so that the option appears. We will create a joint at the base here to represent the start of our character's spine. Then to the middle of the neck, where the base of the skull and spine meet. And then finally at the top of the head. Press Q to quit. At the base of the spine, we are going to create joints where the trapezius muscles are and the shoulders. This will be for instances such as the character shrugging, moving the shoulders while keeping the shape of the trapezius muscles in check. We're going to create another joint from the middle of the neck to extend out where the Adam's apple is. This is also for not only keeping the shape of the neck for when the jaw moves, but also for when the character swallows, in which the Adam's apple moves slightly up and then back into place. Now before we go any further, I thought I should mention something right now that is very important. When you create your joints, you name them immediately. You do not want to spend most of the time trying to figure out which joint is which when that time could have been spent animating the character. Believe me, it isn't pleasant in the slightest. I typically use at the beginning of the names L_, C_, and R_ to indicate left, center, or right side of the head, and include DM right after to indicate that these joints shouldn't move. There are a couple of main areas that we will be creating joints for movement. Those areas are the mouth, side of the nose, around the eyes, the eyebrows, and also 2 areas along the cheeks. We will also be creating joints for areas where you do not want movement, such as the bottom of the jaw and the cheekbones, so that they don't stretch out of proportion. Overall, there are going to be a lot of joints in the face, so I hope you're ready. We will now be creating the joints in the head itself, beginning with the jaw area. Start by creating a joint from the base of the skull to just a little bit to the left, where the jaw and the base of the skull will meet. The reason we're doing this is because we want to be able to move the jaw easily with just rotating one joint instead of moving a bunch of joints for every single movement of the mouth. All the joints we're making for the lower jaw will be connected to this particular point. Start making 3 joints for the lower lip here, with one of them at the center shown here. We will then create another 3 just below the previous ones that will just be there to keep the inclined shape there intact. Now we are going to create 7 more for the jawline, with most of them concentrating around the chin area to keep its shape when the mouth is moving. The reason we're adding 2 at the back of the jaw is to show the slight movement of the bottom jaw for when the character is speaking, which adds to the realism. And this is it for the jaw area. Now we will start creating the joints needed for around the eyes. Start by creating a joint with the head joint as the parent, and have it positioned right behind the left eyeball. Don't worry about creating one for the right eye for now. You will see why later. Next you will be creating 2 joints, both of them at the center of the eye and slightly above and below the Y position of the joint's parent, as seen here. The next 2 joints will be coming from the previous joints that will be in charge of movement for the eyelids, positioned as so. Now we will create 2 new joints from the main parent for the eye joints, in spots just below the eyes. These will be here so that when there is mouth movement, the cheekbones won't be dragged down with it. We will also create another joint just off the corner of the left eye for a similar purpose. So instead of trying to recreate those joints for the second eye, we will be using the mirror joint tool to duplicate the recently created joints to the other eye. First select the main parent for the eye area. Next, go to Skeleton, then click the box by Mirror tool. Make sure that Mirror Across is at YZ, Orientation for Mirror function, and for Replace Names have search for L underscore and replace with right underscore. Click Mirror. Saves us a bit of time, doesn't it? Now you may be wondering why we didn't use this for the jaw, or simply do it for one side and then just mirror joint. Well, that's because it would not only mirror the joints you want, but also ends up mirroring the center joints as well, creating quite an unnecessary mess in the process. We don't want to deal with that. From this point forward, we will be creating new joints from the spot where the skull and spine meet. We will start by making 3 points at the center of the head, right along the ridge of the eyebrow, the nose ridge, and the tip of the nose. These joints will not be moving and are meant to keep the nose and the ridge of the eyebrow shape in check. These next 2 points, however, will be moving the corners of the nose for, say, when the character needs to sniff or if they smell something bad. Our next 2 points will be between the corners of the mouth and the nostrils. This is for when the character smiles, and to keep the area flat while the cheeks inflate outward. Since we're by the mouth, we will create 8 joints for the upper lip, 3 for each side of the upper lip, and 1 for each corner of the mouth. Now create 3 joints for each cheek. The joint near the eye is for the muscle that moves up at a forward angle when the character smiles. The other cheek joint is for when the cheeks puff up, such as holding their breath, and also will move inward and outward as the character speaks. The one in the back should only be moved to enhance the look of, say, when the character holds their breath or has a look of anger when they pout. Next, we will be creating joints for the ear. 1 at the center of the ear, and 1 at the bottom of the earlobe. The former joint keeps the shape of the ear in check, along with the spot right behind the lower jaw. The latter joint is for the movement of the earlobe in case of touching the ear. Finally, for the remaining joints in the forehead, we will create 3 joints for each eyebrow for the movement in these exact spots. Finally, for the remaining joints in the forehead, we will create 3 joints for each eyebrow for the movement in these exact spots. Above and between each of the eyebrows will be 2 more joints that will help keep the shape of the forehead while the eyebrows move. So now we've created the joints needed to animate the head. This is certainly a lot of joints. You can add or subtract the amount of joints to what we currently have if you desire, such as if your character model has a tongue, or if you feel that maybe there should be more to certain spots. Just make sure you save right before the changes, and before we continue with the next step. Now we will go into the most tedious part of the process, binding the model to the skeleton. We will do this by using the interactive skin binding tool to create initial skin weights based on volume manipulators. In English, this means we're adjusting how much influence each joint has on different parts of the model. This involves a lot of trial and error because too little influence means that some small parts that you miss will be stretched out from its origin point when the character tries to move. Too much over a wide area can make your character look just a little bit funny trying to make facial movement. So how do we start? Well, we simply select the main parent of the whole skeleton, and Shift-select just the head model and nothing else. Select Skin, Bind Skin, and then Interactive Bind Skin. At the bottom left, you should see a series of choices for views. Select the Perspective Outliner. You will now select each joint and make adjustments to the weight of the skin. If you feel that you need to insert more joints, go back to the previous save file and add them to those specific areas. You are probably thinking about what to do with the hair, eyes, and eyelashes. It is simple. We will attach them to specific joints, but not with the interactive skin bind tool. Instead, make sure you are in Perspective Outliner views. In the Outliner, you should see the hair and teeth groups and the individual eyes. Make sure the joints in the Outliner have been expanded by pressing the plus by the names. We will now hold-click the hair group with the scroll wheel, and then drag it down to the top head joint, like so. Now when you move the head, the hair will move along with it, without scattering all over the place. We will do the same thing with the remaining 3 objects. Drag down each eye to the main eye joints shown here. Along with the eyelashes at the eyelid joints. If you did the skin binding right, you will have a face that is ready to animate. Try moving the joints and see if you spot any irregularities. If there is something odd, make adjustments or again go back to adding more joints in the previous save file. There is a lot of experimenting when it comes to this, so don't be afraid to try. It's part of what makes it fun, especially after a long, grueling session that ends up rewarding you when you start animating the character. So now you must be thinking, how should I move these joints for the animation? Well, this is how I went about it. Get a mirror and make funny faces at it. Yes, I'm serious. Animators have used references such as this since creating animated cartoons in the early 20th century. Even today, animators do this. For example, when Studio Ghibli was creating Spirited Away, the animating team went to a veterinarian hospital, since all but one of the animators have never owned a dog, and couldn't understand director Hayao Miyazaki's description for how the dragon being force-fed the medicine should look. They brought a camera to record for later viewing and study. After experimenting for a while, you'll notice that having to painstakingly create each expression is rather time-consuming and tiring. Well, this is where the subject in our next video will discuss, which is the shape-based method. Until then, see you later.